Hello everybody. So today oh god, difficulties. I am gonna work on a little home automation project. Now I'm not gonna get into what this is for now because I think it'll kind of detract from what I'm actually trying to do here. So this little power strip is actually a neat little toy that I picked up at a surplus store. So it looks like a normal power strip, except it's got this little sensor port here. Now I've gone ahead and I have attached the cable, which is just a a 4-pin little telephone clippy 4P 4C. I think is the type of connector. Anyway, and I connected that to a aerospace connector. Sorry, aviation connector, because they're better. And they look really cool, and they're locking, and I like them better. Anyway, so what happens is, this is actually supposed to go off to this little sensor. And when it detects motion, it closes a switch, and then turns on all of the banks down here. And when it doesn't detect motion, opens the switch, and you're home free. It shuts everything off. And the idea is, you put your desk lamp and your fan or something on this in your office so that when you walk away from your desk at night, it shuts off everything. I am not going to use it for that. I'm actually going to take advantage of the fact that this thing is a nice relay with all the protections and, relatively high current rating. I open this up. It's a very nice relay in there. And a nice little power supply, and I am going to use this to power a ESP 8260 something module here. One of these, you can get them on eBay. And I'm going to make a Wi-Fi connected relay. Now, I'm going to finish my cheese. It's very important, because cheese is good. All done. Now, I'm going to get to it. Alrighty. So, the view everyone's wanted. Huh? Alright, so, what I got here now, got the aviation connector, and I've already tinned the bits here. Let's see if can I get a little lower here? Ooh, the light. The light is difficult. Just focus on it, man. It's not that hard. No, it can't do with it. Okay. And so basically, I'm going to put together a little pigtail here, because I genuinely don't remember what wires I connected to what. It's a difficulty of mine. I don't really take down the info I should when I'm wiring all this stuff. So, alright, that's good. That's good. Alright. So, alright, we're gonna go ahead and tin this stuff. I'm assuming everyone knows how to tin wires. I actually have a brand new solder pot that this would be really fun to test out with, but I'm kind of afraid of that thing. Those of you who don't know, solder pot is basically you take solder and you melt it in a big pot, and then you just take the end of the wire, dip it in flux, and then dip it in the molten solder. And it makes a really nice tinned connection really quickly. It's more for, when you're manufacturing wiring harnesses and stuff, but, I can have fun too. Alrighty. So, we're going to wire this together so that yellow is pin 1, and you definitely can't see this, but it does, these nice aerospace connectors actually do They're big enough that they actually label their pins. Another reason I really like these. Boy. Well, that's not awful. Alright. We're going to trim these down. Now we're going to do it. So yellow is 1. Orange is 2. Red, which you probably can't see me doing this anymore. And red is 3. Come on. And then brown is going to be number 4. Look at that. Beauty. Alright, so we got our wiring harness now. And what's actually really great about this is... Oh, focus, come on. Woo, 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 woo. Well, can we do this? Does this work? This does work. Cool. Alright, so we now got this wiring harness here. And we are going to throw her onto the breadboard here. So basically, my main problem, well, first we're going to attach our connector. Ooh. Fun. I mean, come on. If you don't enjoy a good connector, who are you? Alright, and then we're gonna go ahead and just shove our leads down into there. Alright. Now, I'm going to plug this into the relay, which is down here. I've been using this for power tools, because, you know, shame. And now, we're going to take out my wonderful, extremely high quality, trust in Radio Shack to be mediocre at best, power supply. And we are going to measure the voltage between all of these pins. Now, I seem to remember that one of these is ground, and one of these is 12 volts. Alright, so that's nothing. That's nothing. And that's nothing. So, I'm pretty sure brown, and I remember this, one of these is a no connect. It's only 3 wires that are actually used in this thing. Oop. Negative 0.5 volts. Minus 12. Okay. So I think... Alright, so we got 12.16 across the red and yellow. And about 500 millivolts across there. Now, what about across here? Yep, okay. So, now, I don't know if you can hear this, but, so this is our control wire, and this is VCC. And so if I go like this, it's actually actuating the relay. So let's figure out what kind of current draw we got here. So we know it's about half a volt. 40 microamps. That's pretty good. Now the other thing I wanted to know was what is, because I sure hope they put a current limit on this. Alright, and so we get a short circuit current of about 40 milliamps from the output here at 12 volts. Let's make sure I didn't break it. It probably was a pretty dumb thing to do, honestly. Yeah. Oh yeah, we're good. We're good. My guess is that's just a pure, what do you call it? Gotta drink some wine here. Pretty sure that's just a pure 12 volt from a little transformer on there or something. Alrighty. So, we've got two things I want to do here. One is I want to make this this path here that turns on the switch here quite nice and skookum, because I don't want my micro to blow up if something stupid happens. So I'm going to look through and see if I have any optocouplers to run that. And then for the power supply, I will be using a 7805 that then will throw out the power to the ESP8260 majigger. So, and then we should be able to get it all set up. And then I'm going to solder it onto the development board I'm actually working on that has a Wi-Fi MQTT temperature controller. And then we'll actually be able to control the temperature of things with it, which is really exciting because so far it has not worked like that. So, I'm get started. It's always important to have your box of junk be organized, huh? We've got a 78L05, which I like because it's smaller. Now the question is, do I have any optocouplers in here? Dear God, I do. Check this out. So, good source for optocouplers here, which you have no idea what these are. I will show you later. Is old computer power supplies, believe it or not. If you find a, go to a flea market or, I don't know, through someone's trash, dear God, you can get these things, and I mean, they're big, single-sided through-hole boards. You can just turn them upside down, hit them with the heat gun, and just yank all the parts out. I mean, at the very least, oh, man, at the very least, you get some sweet MOSFETs. Alrighty. Now, another thing I need to point out, yes, this is a 3.3 volt device, but the boards that I have these on as the carrier has a 5 volt 3.3 volt adjustable jigger on it. So it's all good. Don't worry about me. Okay. Alright. So we're back, and I am going to, in behind the scenes here, pull up the datasheet for this guy, which, no idea if you'll actually be able to read this. Come on, go into macro mode. Macro mode. Seriously, it's... Why are you not focusing? There we go. Well, you can probably see that a little bit. My God. Anyway, it's a little 7805, but it's the 78L05, which means that it actually is lower power. 78L05. Yeah, so it's a TO92 package. And the L05 is a peak output current of 140 milliamps. Let's find something out here, because I don't know what the current requirements are. Okay, so we can't actually use this, because this will actually put out, this 7805 little old guy will put out about 100 and put out about 100 and something milliamps, and ESP is probably going to draw about 800. And then we've also got this nice screen that I'm going to be driving with this, so we're just going to go ahead and straight develop this with the 7805 CT, which is a far more powerful guy. So, these are extremely simple little circuits to build. So we're going to do the voltage regulator portion of this first, because the LO5s I think also have a lower quiescent current, so that's pretty neat. Hold on, I think I'm being called. And we're back. Okay, so pinout for these is basically you have an input, the ground, and the output. And man, these things, I need a new camera. So first we're going to disconnect this from power, and we have the input on there, and then ground is that one. And remember, that's the control wire. So now that means we're going to have the output over here on the left. Now, important thing about these is that you can't just hook them up the way that I've done it. And the reason for that is electrical noise. You've got an amplifier in there, and if you don't snub away any high frequency components, you run the possibility of getting oscillation. So yes, it will work fine until it doesn't, and you don't really want to know what happens. So what I'm going to do is clip these so they actually, these capacitor values aren't critical. At least the input one can be as big as you want. The output one, you really want like a 0.1 microfarad, nice tantalum or so. I've got these, which I have buckets of. These are, the number on them is 475, so that's, I don't want to do math. Anyway, someone knows what these are. Look at that, and now it's focusing to the little guy. He just likes that color better. Alright. So, now, we've got a nice 5-volt output and our fancy little ground. So, we're going to go ahead and connect this up. No smoke, no fire. It's actually a legitimate name of a test, I would like to point out. And we get, you can't see it, 5 volts. Honestly, the amount that's off is legitimately the accuracy of these things. These are not good voltage regulators. They're just dirt cheap. And just to be certain, if we ground the middle pin, it works. Alrighty. So now we're going to use this little guy here. Now, this is an NEC either 2561 or a WH323. And it's difficult to say, honestly. With these little parts that you pull off of stuff, what'll happen is the people will, especially when you get them out of big commercial stuff, they'll actually order these, but they'll have a custom part number that gets assigned to a certain way that it's been trimmed, or you know, a certain process variation because they wanted it to have another millivolt or something. I don't really get it, but you know. So we're gonna Google NEC 2561. Hey, comes right up. Neat. So we get our pin out. Yeah, here we go. This one's by CEL, but that's fine. Basically, the way this works is there's an LED on one side and a phototransistor on the other side. And so what happens is when current flows through the LED on this side, it allows current to flow this way on that side, which should open and close our thing here. So this is going to be operated by 3.3 volts, and the LED gallium arsenide LED yada 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 diode. Forward current is 80 milliamps for maximum rating. Diode. Forward voltage. IF 10 milliamps. Yeah. Okay. So we should really just assume, yeah, RL 100 ohms. Yeah, but it's 45 grams. It's saying a 50 ohm. Alright. So we're going to do a 100 ohm resistor. So we've got a 100 ohm resistor, and that is going from pin 1 over to here, and we're just going to assume that this is our 5 volts here. And then if we ground this out, it works. Now what we would expect for the output current for this, so you've got a 100 ohm resistor and we're giving it 5 volts, and the forward voltage on this diode, which by the way changes with current, is about absolute maximum ratings. Come on. Absolute max diode. Forward voltage is about, we'll call it 1.25 volts. Sorry, we'll call it 1.5 volts. It's really not an accurate thing here. So 3.5 volts. So without the calculator here, because I'm lazy, and 3.4 volts, right? Because V equals IR divided by 100. So we're putting 34 milliamps for that at 5 volts. Now, if we have a maximum diode forward voltage of 1.4 volts and we're using 3.3 volts, oh, backwards. So now we're doing 1.7 divided by 100, we're doing 17 milliamps, and the forward voltage should be about 10. And so, perfect. This is absolutely perfect. And my guess is that we can actually go higher on that load resistor, but honestly, it's not that critical. So, I'm going to write down the pinout of this, and I'm going to tape it around here. And this is really satisfying. Yeah, and just to prove to you that this is actually clicking here, we've have a little thing here. So I've got this turned on, and when I connect this, neat, huh? Alrighty. Until next time, c'est la vie. Or, I don't know, there's some real words for that.